Hi, and welcome to the DRO segment on installing a magnetic digital readout kit onto a milling machine. This video is the third of a four-part series and shows you exactly how to install a magnetic scale onto the y-axis of your mill. Now, if you haven't seen the previous two videos, I would suggest watching them now because each video builds on the previous segment's material. All right, so let's get back to the mill and install the y-axis scale. Now, in our earlier videos, we looked at installing the y-axis scale on the right side of our mill. And what we saw is that installing the scale on the right side might be a little bit more difficult because of the jib screws and the table lock we can see here. So let's go ahead and take a closer look at the left side of our mill. So here we can see that along the left side of the base, it looks to be a much better place to mount the scale. There's a lot more room, and if we hold the scale up, it looks like we don't even need to shorten it. So it definitely makes sense to mount the y-axis scale on the left side of our mill. The bottom line then is that mounting the y-axis scale is going to be an easy installation. Next, let's figure out how we'll mount the read head. You may have noticed that we've removed the x-axis scale cover to give us a little bit more working room and also to give you, the viewer, a better look at what's going on. So this is where it really pays to take your time, sit back, but most of all, be creative. If the way you're trying to mount the scale doesn't seem to be working, there's probably a different way to mount it that you might not have thought of yet. Remember, make sure to take a look at the hundreds of customer installation photos on the installation page at www.dropros.com. All right, so if we do mount the y-axis scale flat against the side of the mill, the read head will then need to be mounted to right along the side of the scale like this. But if the read head needs to be positioned against the scale, then where and how do we mount the brackets to hold the read head in place? Now, at first glance, the most obvious place to mount the brackets might look to be right about here against the end of the saddle. But there's a problem with that. If later on we decide to add a power feed attachment, it attaches to the end of the table here. And if we had the bracket attached to the underside of the saddle, we couldn't move our table full travel to the right. So in anticipation of possibly adding the power feed later on, I think it would work better if we attach the first bracket to the back of the saddle and then angle it towards the back like this. And then if we mounted the second bracket against the first bracket like this, then we should be able to use the tapped holes already in the second bracket to hold the read head in place. But because we want to mount the bracket to the back of the saddle, we can see that an unmodified bracket is not going to fit very well. So obviously we'll have to modify the first bracket a bit. But remember, that's all part of installing a DRO. And I really don't like the way that the second bracket would end up sticking out so far. So I'm also going to shorten one leg of the second bracket a bit. Okay, so let's take a break and customize our brackets to fit exactly the way that we want them to. All right, so here we are with our modified bracket set, and on the first bracket, I've already put some exterior mounting tape on the back of it, so let's go ahead and put it in position and see exactly how it looks. So that looks pretty good, and you can see now that it clears the underside of the scale and the table. And because we also removed the top edge along here, it also no longer sticks up so much. Now finally, the second bracket will be attached via the slotted holes along the side like this. All right, so I really like the fit on the brackets right now, so let's go ahead and mount them. Now the first bracket is held in place using 2 of the M6 by 20 millimeter bolts found in the universal mounting kit box. So these would require drilling a 5 millimeter pilot hole. But first, I'll go ahead and center punch the hole. Then I'll remove the bracket and then drill the hole. Now, I also want to make sure and check my hole depth to make sure of 2 things. First, that the holes are deep enough, and second, and possibly even more important, is that I don't drill the holes too deep. Now, make sure to take your time and drill just a little bit at a time. And next, I'll start by tapping both holes with the M6 by 1.0 plug tap. And next, I'll finish both holes off with the M6 by 1.0 bottom tap. All right, so with both holes drilled and tapped, let's go ahead and install the first bracket. Next, let's go ahead and attach the reed head to the second bracket. To do that, I'll use the M4 by 20 millimeter cap screws. And then we'll attach the 2 brackets together using the M6 by 20 millimeter cap screws from the universal mounting kit box. So now we can really see how this is coming together. And all I have left to do now is to mount the Y-axis scale. And really, I've got plenty of room and there's lots of play in both of my brackets, so mounting the y-axis scale should be pretty straightforward. Okay, so to start with, let's move the table all the way to the very rearmost position. So we'll start by putting some mounting tape on the back of the scale, and then we'll do a test fit just to make sure that everything's going to fit together correctly, as I don't want to accidentally mount the scale where the reed head might run into the end of it. So with the brackets in the middle range of their total adjustment, it looks like right about here is a good place to mount the back end of the scale. So next, let's bring the table all the way to the front. And with the table moved all the way to the front, it looks like the front end of the scale should be attached right about here. All right, now so far this looks pretty good. I've run the table all the way to the back stop and then all the way to the front stop. So now I know the reed head won't accidentally hit the ends of the scale if I move the table all the way to either end of its travel. And keep in mind, if we do need to adjust the position of the scale a bit, we've still got quite a bit of play in both the scale end caps and the reed head brackets. So let's drill some holes and get the scale mounted. Now I'll start by first drilling some 3.3 millimeter pilot holes. And next, I'll remove the scale. And then I'll tap both ends, starting with the M4 by 0.7 plug tap, and then I'll finish both ends with the M4 by 0.7 bottom tap. All right, so let's mount the scale. I'll be using the M4 by 16 millimeter socket head cap screws. But remember from before that we want to mount the scale and the reed head so that the hash marks on the side of the reed head and the hash marks on the side of the scale both end up on the same side. And since we're mounting the reed head with the cable going towards the rear, the orientation of the reed head will really determine how we mount the scale. So if we look at the top of the reed head, we can see that the reed head hash marks end up being on the top side. Therefore, we want to mount the scale so that its hash marks also end up on the top side. Now, the other thing that's different about the y-axis is that this time we're not mounting the scale to a machine surface, like the x-axis scale was. So what that means is that we need to check the alignment of both the vertical face of the scale and also the top edge of the scale. Now, just to give me a little bit more room to work, I'm going to first remove the second bracket and the reed head. And to be clear, the reason we wanted the reed head in place was to give us an indication of exactly where I needed to mount the scale. But now that that's done, leveling the scale will be a lot easier with the bracket and the reed head out of the way. All right, so I've set up the dial indicator against the face of the scale, so next I'll zero the dial. So now I'll run the table to the front and I'll see if the face of the scale is parallel to the travel of the machine. And I can see here that the dial indicator is decreasing in value as I move the table towards me. This means that I need to raise this end of the scale until the dial indicator zeroes out to make it parallel with the far end of the scale. Now, another nice feature of the electronic and magnetic scales is the built-in grub or set screws, which I can now use to raise the end of the scale. With other brands of scales, you'd have to stack shims to level the scale, which would take much longer and be a lot more difficult to install. So let's take a closer look at the grub screws. Notice that there are 5 total screws with an inner pair, an outer pair, and then a single grub screw at the very end of the scale. For what we need to do, we need to equally extend both the inner and the outer pairs until we've raised the scale far enough to bring it into being parallel. Now let me explain what would happen if you only use the single outside pairs of screws to raise the height of the scale. Yes, the screws could raise the height of the scale the correct amount or distance you wanted, but then when you tighten down the larger bolt that fastens the scale to the side of the mill, the scale would bow inwards more and more the more that you tighten down the bolt. So to keep this from happening, you need to extend both pairs or sets of grub screws an equal amount. Now, one last point. If your scale is bowing outwards or inwards, then you can use these pairs of grub screws to offset that bow. But for us, right now, all we need to do is to raise this end of the scale. So let's go ahead and do that. All right, so the first thing I need to do is to loosen the bolt that holds the scale to the mill. And as I loosen the bolt, I can see that the scale is naturally lifting away from the surface of the mill. So I'll simply loosen the bolt until the dial indicator zeroes out. Next, I'll equally extend both the inner and outer pairs of grub screws until they contact the surface of the mill. Now I'll go ahead and tighten down the bolt that holds the scale to the mill. Okay, so that looks about right. Now remember though, it is a combination of going back and forth between the grub screws and also the bolt that holds the scale to the mill. So you might have to go back and forth a few times. But right now, let's go ahead and run the table back and forth to make sure that everything's truly parallel. All right, so next we need to check whether the top edge of the scale is in alignment. I'll reposition my dial indicator against the top shoulder of the scale. So for you to be able to see the face of the dial more easily, we had to change to a plunge style dial indicator. But now that that's mounted on the top edge of the scale, let's go ahead and run the table back towards the front. And so I could see that the dial indicator value was slowly decreasing as I moved the table towards the front. This means that I need to raise the front end of the scale until the dial indicator zeroes out. All right, so I think that that looks a lot better. Now, officially, the deflection should be less than 0.1 millimeter for every meter traveled. And of course, we want to get that dial down as close to zero as possible. Now, not surprisingly, what you have to do here is to keep going back and forth between adjusting the scale and then rechecking your results. Now, inevitably, you're probably going to get some deflection, especially with our longer scales. Just remember to take your time and correct one axis at a time. All right, so at this point, the scale is mounted parallel to the travel of the machine. So next, we need to set the gap between the reed head and the scale. So let's go ahead and reinstall the reed head. All right, so while we were reinstalling the reed head, we remembered to put the shim between the reed head and the scale. And we remembered our technique from before to leave a little bit extra hanging out at the end. So at this point, all I need to do is to readjust the brackets in and out until I get the correct spacing between the reed head and the scale. Next, I'll move the table while I hold the shim in place with my finger. If the spacing is correct, the shim should just slide out as the reed head moves backward. And here's the shim, so the spacing looks good. And finally, we'll make a complete run of the table through its full travel front to back. And just like before, we need to make sure the reed head doesn't bind or dig into the stainless steel cover. Remember, check all the way front to back, full travel. Now, because the bracket to hold the reed head comes down from the top, there's really not a very convenient way to mount the scale cover. But I'm not really concerned about that because the scale and the reed head are both coolant and dustproof. And second, the scale is mounted sideways, which will keep all of my swarf and chips from accumulating on top of it. Remember, the scale and the reed head are both IP67 rated, so the cover is not really a necessity. Now, the most important thing to remember is that there is no one correct way to mount a DRO. Everyone is going to have their own idea about what's the best way to mount it. Remember, the only real rule is to be creative enough to get the job done. All right, so that concludes the installation of the Y-axis scale.